all got into MIT. Only 5 to 7 students at that time used to get into MIT. And there are many other rappers. For example, Microsoft GitHub Copilot is a rapper. Now, in 2024, we are reaching the era of agents when they can actually act like you. Can you share what are the futures of job in the world of AI you see around you? So hello everyone, today we have Sagnik Anupam, who needs little introduction because in 2020, he first of all got into MIT. Only 5 to 7 students at that time used to get into MIT. And plus, he has been up to date in the era of AI innovation. His classwork, he just explained me that it's up to date even till the innovations we have seen till GPT-3. MIT is very fast moving and we will get to learn more about AI with Sagnik. So hi Sagnik, can you please introduce yourself?
So hi everyone, I'm Sagnik. I am a recent graduate from MIT. I just graduated a few days ago, and I am going to start my PhD at the University of Pennsylvania in fall, and with a focus in programming languages as well as machine learning. So yeah.
Amazing. So let's start with 3 reasons you think that you made it to MIT.
All right, 3 reasons. Well, okay, that's I'll have to narrow down a lot of things. I think the main reason that I feel like really shone through was sort of my passion for working on research and working on research projects. When I was in high school, I worked on a bunch of research projects as well as a bunch of like STEM projects that really interested me. And I think that some of those like projects were really instrumental in my application and talking about what I learned and how I did those projects. I've been working in machine learning since roughly about 10th grade or so. So that's when I first got involved with machine learning. And so, yeah, working on machine learning projects, working on linguistics and other sort of tangential fields related to machine learning was sort of the main driving force behind like what I did in high school. So yeah, that was that. I think obviously I think marks are important. So I would say that I think I had acceptable marks in my high school. So I think I checked off the boxes regarding that. And then I think finally I think that a good application like has a powerful essay and like tells a story in a compelling way. And well, I don't have any feedback on my application, but I think that it got the job done. So yeah, so I basically talked a lot about my passion for machine learning, my passion for research, some of the linguistics competitions I did, like the Olympiads and stuff. And so that was basically what, and this combination of machine learning and linguistics is what I mostly put in my application.
Incredible. According to the CDS score as well, if you have heard common data set for MIT, that also says, academics are top there to get into MIT. So very well said. So can you please share 3 most inspiring innovations that have recently happened in AI that have influenced you a lot?
So I will preclude that by asking how recent. So what's recent to you?
I think last 2 years, since the era of GPT-4 or GPT.
Okay. So I think some of the things I'm most excited by, the first one is alpha geometry, which came out in January. I think it's super exciting. It is a machine learning model that uses large language models as well as some traditional symbolic methods, and basically is able to solve IMO geometry problems, which are super difficult and like is just a crazily difficult task. And the performance that we have seen in those models is like amazing. So I think that's really exciting. So solving IMO math problems using AI. The second sort of main innovation that I think was also really exciting. So it goes back a bit further. It was using similar techniques for program synthesis, which is the sort of the task of generating code using machine learning models, and as well as other like traditional methods. So I think a good hybrid example of this was Dreamcoder. And the third the exciting project that I discovered was updating Dreamcoder using large language models. So you swap out one of the components in Dreamcoder using an LLM, and then you get like amazing boost in performance. And that paper was called Lilo. So Lilo, Dreamcoder, and alpha geometry are sort of the 3 like advances in AI over the past few years that I think are really cool and really amazing. And they sort of like led to each other. So Dreamcoder's architecture influenced Lilo, and then we see like LLMs being adapted more and more across different tasks. So that's where alpha geometry came in with the math domain. So yeah.
Incredible. Would you define Dreamcoder similar to GitHub Copilot to generate code?
I think the main difference in Dreamcoder is so Copilot is what I think the architecture of Copilot broadly is mostly LLM focused and LLM based. Dreamcoder had a very simple neural network. Like it does not use billions of parameters. It does not use like a large language model at all. And the idea behind a Dreamcoder is basically to have like have a neural network that is used for a sort of predicting which chunks of code are like good, like in terms of solving a particular problem or a particular task, but there's like other systems that are working to constantly refactor the code and come up with basically good submodules. And so the main power of Dreamcoder is not really generating like long strings of code to solve a problem. It's basically finding like useful tactics or techniques, which are these small submodules that you can chain together in order to like solve like a crazy like big problem. So a quick example of that would be like, for example, if you're trying to devise a sorting algorithm, the first thing that Dreamcoder does is like try to find a simple like sort of piece of code that can like swap different elements in an array together or something, right? And then you combine those, like what sequence do you do the swaps in? What are the conditions under which the swaps occur? And so it keeps iterating on these and sort of filling in these holes until it comes up with a complete sorting algorithm from beginning to end. And it can do that knowing just like the programming language that you're using and the task that you're like the input and output for the task that you're trying to solve. And you would not need to train it on like you wouldn't need to train it on the whole of GitHub. You don't need to train it on like all these like large code bases. And so I think that's really powerful.
So it's more of algorithm than AI and LLMs, right?
It is a neurosymbolic model. So it uses like a neural network to do the prediction. So it has some AI in it, but the refactoring is done by algorithms. So there's a lot of like program analysis research that is used in order to find what is like a good program or a good solution.
And what was the third one you said?
So the third one is called Lilo. Lilo substitutes one of the ideas behind Dreamcoder is just enumerating a lot of programs and checking them to make sure that, like, you know, which ones work, which ones don't work. So the idea is that the large language model is generating some of these abstractions and like rewriting this code so that it becomes more understandable to humans and also helps the model learn how to solve these problems much faster. So that's the main idea. Yeah.
थर्ड पार्ट को थोड़ा सा हिंदी में ब्रेक कर सकते हो?
एक तरीका है LLMs का जिसमें हम सारे लाइक प्रोग्राम्स को हम एनालाइज कर रहे हैं थ्रू वन मॉडल, राइट? एंड देन हम ट्रीट कर रहे हैं उसको जैसे कि नेक्स्ट लाइक टोकन प्रेडिक्शन टाइप ऑफ टास्क है कि नेक्स्ट लाइक क्या टोकन है सीक्वेंस में विच वुड कंप्लीट द प्रोग्राम. इन other second type of models में क्या है, you treat a program as something that has holes in it and you're trying to fill those holes. तो जैसे एक फंक्शन कॉल मिसिंग है, ठीक है, वहां पे फिर क्या इंटीजर आएगा, स्ट्रिंग आएगा, क्या आएगा वो फंक्शन कॉल में. So you fill that in and you keep chaining these functions together like more functional programming type of approach. तो उससे फिर क्या होता है, एक sequence of functions बन जाता है और वो sequence of functions can solve your task. So you can write an insertion sort by chaining functions together like you do in Lisp, or you can write it like as a Python, like मतलब हर एक syntax को याद करो, like model से syntax सिखाओ and all that. So those are the two different approaches.
समझ गया. So, to give some background to the audience, so there is, these LLMs are based on supervised learning. जैसे अगर आप hello, or let's say you train a model based on a name like hello apple, hello orange, and now next time you're trying to predict, if you just write A, it'll automatically say apple. That's how supervised learning works. Now, you are breaking it down into chunks of code and then training on top of that, right?
So what it can do is it can examine the code it already has in its data set, and फिर उससे it can like generate, like if you give it a task like, oh, generate a sorting algorithm for me, it can reference that and generate you a sorting algorithm. In this case, sorting algorithm में हमारे पास कोई actual code नहीं है in between, like in our training data set. हमारे पास बस एक task है which says this is an unsorted array, this is a sorted array. अब आप figure out करो कि ये language के अंदर हम इसको unsorted array को sorted array कैसे convert कर सकते हैं. And that the model can learn to do on its own. थोड़ा उस एरिया में अनसुपरवाइज्ड है कि हम उसको बता नहीं रहे कि क्या what is a good example of a good code. So it's discovering programs by itself, filling in those holes in those programs and chaining them together so that एक के बाद एक function call कर करके हम finally एक unsorted array को sorted array convert कर सकते हैं.
Now to give some related innovations that are very much connected. So 2023 was the era of LLMs plus their wrappers. For example, Perplexity is just a wrapper, but it has become a unicorn. And there are many other wrappers. For example, Microsoft GitHub Copilot is a wrapper. Now, in 2024, we are reaching the era of agents when they can actually act like you. Now, we haven't reached there yet. Now, can you share what do you think is the future? Like, is wrapper is the highest level of innovation we can imagine? Is agent, or we can imagine even innovation beyond that level?
So I think that, well, I think wrappers can then be, there's lots of like fine tuning and architecture stuff going on. So I think there is, of course, a lot of innovation because a general purpose large language model might not be the best model for your task. You might actually decide that you want to fine tune it more on specific custom data sets or proprietary data sets that you have, which in turn will like might make like the large language model perform very well on your task. So that is a thing that we have constantly been seeing. So for a lot of AI wrapper products, like it's not simply just a call to like a general large language model. So I think that's very exciting that we're going to see more and more about the limits of like fine tuning and what we can actually do in order to overcome those limits and what kind of like data we actually need to overcome those restrictions on like sort of what the performance restrictions on general purpose LLMs. Agents, on the other hand, I think are really interesting because so there's in traditional like sort of optimization theory, you have something known as like swarm intelligence, which is this idea where if you have a swarm of different agents that are all sort of identified by some variable and they are all working towards the same goal. So you have some hyperparameters that are identifying these agents and then they're all working towards the same goal. Where do they converge is like a very interesting question, and this is often used in order to solve optimization problems. So if you ever wonder what is like a good architecture for a neural network, or if you ever wonder how do you like find the optimal weights and biases of like the neural network, these kind of problems have often, obviously there are like existing like non-swarm intelligence methods, but there are also swarm intelligence methods where you just give like a bunch of randomly initialized like sort of agents, sort of a metric to optimize by, and then they converge onto this optimum metric.
Can
And
you
that is
sorry, can you break down swarm intelligent methods? I'm sorry, I'm not as in touch with the
नो वरीज सो स्वॉर्म इंटेलिजेंस में ऐसे होता है कि अगर आपके पास लाइक बेसिकली यू हैव लाइक 30 सॉर्ट ऑफ एजेंट्स, राइट? यू इनिशियलाइज देम रैंडमली एंड देन आप डिसाइड करते हो कि हर एक को बाय सम अपडेटिंग मेथड यू अपडेट ईच एजेंट्स पोजीशन in like sort of 2D, suppose 2D space. Suppose you have like, so try to visualize like a bunch of birds basically flying around. Like, so they're flying at random at first, right? And then what you're doing is you're trying to update it to find what is the best solution. तो अगर एक graph है आपका function का, which is like I'm trying to find the minimum of this graph, which in this case is minimum error rate or something, some sort of metric like that. तो आप multiple agents को लेके आप फिर उसमें क्या कर रहे हो? आप उनको direct कर रहे हो find the minimum, and they're going to come at the minimum from different positions on this 2D plane. क्योंकि वो लोग randomly initialize different positions में भेजते हैं. तो ओवर मल्टीपल इटरेशंस ऑफ दिस इवेंचुअली कन्वर्जेंस हो सकता है, पॉसिबल है, डिपेंडिंग ऑन द फंक्शन दैट यू आर सीइंग. तो कन्वर्जेंस अगर पॉसिबल है देन देयर माइट बी एन ऑप्टिमल सोल्यूशन टू योर एंटायर ऑप्टिमाइजेशन प्रॉब्लम. सो ट्रेडिशनली जब ये होता है, ये जैसे कोऑर्डिनेट्स के फॉर्म में हो रहा है, लाइक रैंडमली आप कोऑर्डिनेट्स इनिशियलाइज कर रहे हो, बट नाउ विद एलएलएम्स यू हैव कॉन्टेक्स्ट. सो आप इनको रैंडम लाइक कॉन्टेक्स्ट में कर सकते हो. लाइक यू हैव वन एजेंट का बिहेवियर स्पेसिफाइड इन वन वे, यू हैव अ सेकंड एजेंट का बिहेवियर स्पेसिफाइड इन अनदर वे, एंड फिर उनको आप एक एनवायरनमेंट में छोड़ दे रहे हो टू फाइंड द ऑप्टिमम लाइक वैल्यू. So this has lots of interesting applications. They say, what is the best neural network architecture? What is the solution to this like long-standing math problem, which is like just very, very difficult to compute, like using traditional methods. So you can have all these sort of like challenges, which are now like your agents are slightly more intelligent than traditional agents, where you just have like a hyperparameter or two, या कोई एक simple mathematical function से वो agent define हुआ है, but यहाँ पे आप LLM से agent को define कर सकते हो. So that is the exciting part.
You mentioned you work on neurosymbolic machine learning models at MIT. So can you share the concept of neurosymbolic AI and potential advantages and the relationships you have seen between, how we as human beings are intellectual versus neural networks?
Sure, I can try to answer. Okay, so neurosymbolic AI, first of all, is basically this idea that you don't have to do everything through the neural network. It is okay to have some symbolic module that is like handling the symbolic aspects of data. And what this basically...
Can you break it down? Like, pura word, break down the neurosymbolic. Can you break down the whole word?
Thinking about neurosymbolic models, right? So the neuro part refers to the neural networks, or like the sort of the advances in machine learning, which we have seen over the past, like, I don't know, 40 years or so, right? The symbolic aspect is that you don't have to do everything through the neural network. You can choose to have some sort of algorithms or some sort of like previous knowledge that you have about the structure of the data that you're looking at, and then use that in order to support the neural network. So an example of this is like, and simply is just the idea of like trying to generate code, right? So if you want to generate code through a large language model, you're just generating it through whatever you're prompting the LLM with. But in a neurosymbolic model, you have a neural network which can be used to sort of discover like different like submodules or subprograms that are useful, and a symbolic module that is actually like checking them for like, how good is this? Like how likely is it to like, solve this problem? Does it compile? And like all these correctness sort of issues that often pop up when you just give something entirely over to an LLM. So you don't have to worry about the correctness. You don't have to worry about the sort of compilation times and all these like sort of additional metrics that we know from previous programming experience before LLMs. But instead, the idea is, yeah, you have one component that handles generation and then one component that handles sort of checking and like validating that the code that you're generating is good.
Oh, so it's more like human being. Like one person is creating like an LLM, creating code, creating language, creating intelligence, which is in the shape of language, and other person is checking. So it's like more like an agent model, more similar to human being.
Exactly. So yeah. So the benefit of this and the benefit of this approach is of course that you don't have to worry about correctness from the LLM side. So you don't need to focus on training the LLM to sort of make sure that it's guaranteeing like correct code all the time. Whereas you can just focus on like, maybe it can generate small chunks of code like a decent percentage of the time. And that's kind of so your focus shifts. And I think a great example of this is the IMO, like the alpha geometry, which was basically using AI to solve IMO geometry problems. So the thing is that there's very little training data compared to like the other tasks that we have on IMO geometry problems because fun fact, there are not that many IMO geometry problems around, right? So what alpha geometry did was they synthetically generated a bunch of geometric constructions and they analyzed those geometric constructions like exhaustively, like just checking, is this the midpoint of this triangle, like this side of a triangle, is this angle correct? Like they just analyzed all these random constructions that they generated. And then they had an LLM generate like fine tuned on this and generate like more constructions. And so it suggested to the sort of the symbolic module to, put a midpoint here or like, measure this angle here, stuff like that. So constructions like that, right? And then there was a symbolic module that was constantly checking for properties. So it was just checking, does this midpoint imply that these two are equal? Like it's using all these geometry theorems that it already knows in order to check the relationships between everything. And so this sort of dual pairing where one LLM is generating all the constructions and all the extra like geometric information that you need. And then there's a symbolic module that is checking that this is useful for the problem, this is correct, and this is like what kind of new relations does this inspire and stuff like that. And so these two modules working together managed to solve like a very like just get amazing performance on like the IMO geometry challenge. And that's I think that's really, really exciting when you split up like the neural aspect and the symbolic aspect like that. So that is why I'm excited about neurosymbolic models.
Can it replace humans?
I think it depends on what replacement is. I think I try to think about machine learning more in terms of practical like sort of applications. So where do like people work and like where do these models really, really shine? I think we'll always have IMO geometry problems around because humans like challenging themselves and humans like solving this. I think that at the end of the day, we're going to see that a lot of challenging problems can be augmented by machine learning models, but I'm not quite sure that we are at a point where we will always get 100% accuracy on every single task ever. So I think it's a matter of time. It's sort of too early to say right now about like what exactly can be replaced and what cannot be replaced. But I think over time, what we're going to find out is we have some models that are amazing at some specific tasks and others that are not. So I think it's just going to end up in terms of like that. So it's going to be very task specific.
Let's zoom out a little bit into AI projects. Can you share what are the most interesting and useful AI projects and usefulness of AI you see around you? Is it AI agents, multimodality? Because NVIDIA CEO just said that every country needs to have its own large language model. Spanish, Hindi, Punjabi, or Marathi, Telugu. Every language needs to have their own model so that we can build up on the multimodality and make many models perfect.
So yeah, I think that in general, when I'm thinking about like how global like AI has become, and like how we are seeing all these sort of like local languages that are like, have their own LLMs now. I think some of the most exciting uses for me at least are like, especially I feel like we can do problems like translation and like problems like just massive like text problems that were just not doable at that scale before. Like you can understand like a lot about like massive amounts of textual data that is being gathered. But I think what's more exciting is that LLMs also have like promising sort of like we're seeing that LLMs have a lot of promise even in data that's not strictly like text data. So for example, if you have like data like for example programs, right, code or math equations, and you're seeing these sort of like these new approaches that are coming up in order to solve problems in these domains, I think that is what personally is most exciting for me. So when you have like models that have like so much language, like trained on so much language data, like how do they perform on like other tasks, and how do they understand like non-textual like sort of tasks, and also how do they like what kind of like information are they collecting from the rest of the data set. So for example, if you try to like take an LLM to play like chess, for example, right, it obviously has a lot of data related to like chess games, but it also has a lot of data related to like the individual profiles of the chess players themselves. So like what does it know about like and I use know in the sort of the loosest way possible, but like what can it figure, what kind of relationships can it figure out between like certain opening moves versus like certain like in-game moves, like what's this relation and what's this dynamic, and those things are really, I think, exciting to think about, because so far like a lot of problems that we've seen before LMs have just been, you have this one data set that has like these kind of, it has a lot of these input variables and you have an output variable. So yeah, so you have a lot of this data where the model just looks at the input variables that we think are good for the output variable. But then in a post LLM world, what excites me is that now we have a lot of like language data that it's been collected from a lot of different sources. So how do you use that and then sort of like approach these traditional problems that only had like, chess moves, or only had like medical records, and like only had these like sort of individual like sort of non-text data. So what kind of like relations can you find out between them? So yeah.
Yeah, incredible answer. Now, what are the three dangers of adversarial attacks, AI dangers you have seen around you, and what you have done to stop them?
Sure. Okay, what I've done to stop them is well,
In your, in
okay,
your
I
papers, in
guess
your
I'll
work.
try. I'll try it. So I think a basic one, for example, is data poisoning, right? So if your input data or your training data is just not working the way it is, so if someone has obviously like maliciously modified it, or if someone has like, or if just by oversight you've just missed some component of your data that's not the way it should be, there's a huge chance you can generate something that is like problematic or that is like dangerous, and sometimes things might just end up breaking. And so
Let me add an example. A quick example is just now GPT-4o was jailbroken, and there's a prompt created that can enable GPT-4o to, in fact, tell you how to create bombs, tell you, destroy the world. That was so dangerous. Yeah, go ahead. Sorry.
yeah, so I think that's like that's a very interesting aspect of this, where I think that yeah, so finding out prompts like that or finding out stuff like that can have really bad impacts on end users, and oftentimes like people will be using models in different contexts, right? And we are seeing this more and more with LLMs that were initially released as these sort of like chatbots and chat agents, and they've just grown to be so much more than that. Like I'm seeing LLMs being used for like robotics and for like for language instructions for solving like programming problems, math, and all of that. So what happens if you have like an LLM that generates bad code or like broken code, or like deploy has some security vulnerability that no one notices? And these are all problems that are really really challenging. And I think these can happen through like both like yeah. So obviously you have data poisoning. You also have people like adversarially prompting and prompt engineering these LLMs to produce that kind of stuff. And I think these kind of attacks are just like really, really problematic. What to do to stop them, I think, is just like being really, really careful and having like a system of checks and balances in order to like make sure that your model is outputting what you want it to output. And I think that recent advances in like tackling these sort of issues are like really, really exciting to read about. So you have like you obviously have like manual filters, or like certain like the most primitive form of which is like certain phrases or certain prompts are just blocked from like occurring. But I think that like fine tuning models on specific things to avoid, as well as like reinforcement learning from human feedback, where like a human is in the loop and is trying to like tell the model like, oh, this is a good output, this is a bad output, like those kind of like sort of intensive work being done on the model can help it prevent from like, and specifically speaking to large language models, can help it prevent the model from generating this kind of text. So I think that personally that yeah, we're going to see a lot of like adversarial attacks are now a part of our reality, and like we are going to see a lot of them, and I think that mitigation techniques are just going to evolve with them. So it's going to be like the old cybersecurity versus like hacker sort of dynamic where every new exploit needs a patch, and then every new patch can like lead to a new exploit potentially, and someone needs to check that. And so I think we're going to see a lot of that in the AI world as well.
True. Another example could be like, in your training set, someone can add a stoplight, a stop sign as a green light, if
Yeah.
it's a self-driving car. So, these are very dangerous. Any other dangers you've seen?
I think a fun one was when a checkered car, like a car with a checkered, and so it was not even being identified as another car. It was being identified as like an object that's completely unrelated. And I think that's like a dangerous example of like how like, if you're not really not careful about your data, you can end up with misclassification issues. I think another fun one was, I think if you add some noise to the image of a panda, there were some image like classification models that identified a panda as a gibbon, and I think that while, the day-to-day dangers of misclassifying a panda are not that severe, I think that some poor wildlife enthusiast is going to be very, very sad with that happening. So, yeah, I think that there's definitely interesting like sort of issues around that, and yeah, mitigation is just going to be a challenge going forward into like the future years.
Let's come back to MIT. MIT doing everything amazing in the era of innovation. For example, you are up to date in your classwork from GPT-3 till now. What has happened? You're up to date from transformers, from the first research paper that came out in the era of LLMs. That was, attention is all you need. So
Yeah.
these are things that other universities, not just in other countries like Africa, India, or China, but even in the US, if I go to even like, Georgia State, Georgia Tech, ASU, they also take longer than MIT to stay updated. They also sometimes are not up to date. They just say, yeah, ki, go to Coursera, study from there. They are not at the speed of MIT. So what are the things that students can do to match the level of excellence of MIT?
Sure. I think that like on the first point, I think yes, it takes time for things to come into coursework. I think that's just the progress of science. So I think we're going to see more and more of like I think in a world where we have digital learning like as a possibility, we're going to see a lot more of people incorporating like all sorts of digital articles, research papers, cutting edge development into their curriculum. And I think that this is something that's just going to keep growing. So I think that the way things are today may not be the way things are, even 4 years into the future, where people going into college today are going to be graduating. So I think there's a lot of potential, like sort of, like I have a lot of excitement around like more and more like sort of, reimagining of the curriculum as it exists. So we're going to see like a lot of exciting engineering discoveries being talked about in the classroom. And so that's personally something that's very exciting for me. I think for students, I think that the general thing that helped me was so MIT also puts a lot of its coursework online on OpenCourseWare. So it's ocw.mit.edu. There's a lot of like helpful stuff from our classes, ranging from like lecture videos to lecture notes to like textbook recommendations and stuff. So I think that if you want like an education like where you are sort of like pursuing all the STEM stuff that like other students at other universities are pursuing, honestly, the easiest way is just to like look up what people are talking about in that course, or what are the topics that are being covered in those courses. So you can just search those topics up yourself and like read about more about them. So I think one of the best ways that I sort of like learned about different topics at MIT was just finding something that a professor like randomly mentioned in a class or something, and being like, oh, that sounds really interesting. And then I go back and then I'm looking up like, what is this about? And then before I know it, I'm on some like lecture slide from some other university, and I'm just reading about that particular like niche topic. And I think that sort of learning is really, really helpful. It helps you discover like a lot of different things going on, not only in computer science, but in other fields as well. It also helps you like understand the history of what's going on in your classes. So like, especially in like, at least I can only speak to computer science and math, which is sort of the majors that I pursued at MIT. But in my like in my classes, a lot of things I feel were like better contextualized once I understood why it's important to study them, and like why we got to this point where we are talking about this in the classroom, because not all papers and not all like key ideas sort of make it into textbooks or are discussed. There's just too much research going on and there's a lot going on, right? So understanding where this came from and what the field was like when this idea was published and how it changed the field is like really, really exciting to learn about. So I think that's something that is amazing. And I think for courses in general, I think pursuing courses where your like sort of instructor is like sort of like this is their passion, this is their course, like is amazing. I had the privilege to take like classes which was basically like what you would call as someone's specialty. So the instructor had basically done like years of research on this one topic. They were teaching like a specific like sort of insight into their like how do you get introduced to that kind of work, or how do you get introduced to that kind of research. And so they have all these cool ideas or these cool tidbits that they'll mention in class where you're just learning about what is new in the field, what has been some new development in the field. And because they're up to date on the literature, it's really exciting to learn that. So I feel like for every university obviously has like different like sort of people with different specializations and people whose research interests are very different, but taking classes where the specialization and the professor's like own research field sort of like intersect with this course material is like super, super rewarding in my opinion. So I think that was just amazing. So yeah.
So you mentioned for students, they can start with MIT's coursework. They can continue to learn whatever information that is new in that coursework, explore, go in depth into it. Now, how can institutions can get better, can be at the level of MIT?
I think that generally, I think so. There are a few things that institutions can do, which I think were like sort of like the most like rewarding aspects of my undergraduate experience. I think the most rewarding experience by far that MIT provided was something called the Undergraduate Research Opportunities Program. I participated in it every single semester of my time at MIT. I was just constantly like working with someone or the other on some project. And I think that was really, really cool because a lot of like a lot of research work that you get exposed to is often not research work that you just like stumble across one day, right? It's because someone talks to you about it. It's because someone like gives you like sort of some sort of mentorship and like some sort of help in terms of how do you get introduced to the field. And I think that the mentors and the research opportunities that I had at MIT were fantastic. I think that the people who supported me here were like amazing, and they provided very thorough like sort of explanations and introductions to like their particular specialization. And I think that just having that sort of like close, like one-on-one time with an individual mentor, an individual researcher is like so, so helpful. And I think that more universities should have such kind of opportunities for undergraduate research. I love to see like, like there are like whole, like nowadays there are like whole conferences dedicated to undergraduate research and just undergraduate research. And that's really, really exciting for me to see because that is what shaped most of my MIT experience. So I think that's by far the biggest one. I think in terms of education, I also think that like having sort of there's so many like sort of optional classes and electives at MIT that are just, super cool and just like super exciting to think about. So when you're flipping through the course catalog, you really are spoiled for choice. You're like, oh, I want to take this class. I want to take that class. This class is only being offered this one, like sort of like once every 2 years or so. And it's being taught by someone who's like absolutely like, the last 4 papers they published were on this topic, right? So I think that like really tying like classes together with people's specializations is like really what makes like a department like feel like home to its students, like feel where students get excited about the classes that they're taking. Because I think that I think that in general like taking these kind of classes or offering these kind of classes is very, very cool. And also I think updating them frequently is also like super important. Like I've seen classes that have like that were taught one way when I started at MIT, and now that I'm graduating and watching other people take this class, it's totally different. Like I can't even recognize it. And that's sort of like even within 4 years, that level of like drastic change is like I think it just speaks to like how passionate sometimes like professors are about like teaching students like what's new in the curriculum or like what's new in research. And I think that's like super just super amazing in general. Like I think that that sort of dedication and that sort of like passion is just it makes students feel excited about the subject. And at least like many people I know who did undergraduate research did it because they were interested in a topic because a professor like talked about it in a class, and then they went up to the professor afterwards and they talked to the professor about that topic and like ended up like doing research in that topic. Like that is something that happens way more often than you would think it does, and it's just so amazing to see. Yeah.
Totally agree. The earlier you start, the better you become. I can totally say that people who are starting now at sixth grade into AI, seventh grade, it might be funny for some people, but they are becoming better AI researchers. There's surely like a pattern. People who start early are becoming better engineers. People are becoming better AI researchers, programmers, engineers. Now you're going for your PhD. Can you share what are the futures of job in the world of AI you see around you?
Yeah, sure. So I think that AI is definitely like I've seen a lot of people like working at AI companies and a lot of like new postings for AI researchers and AI scientists. And just I think there's a lot of potential and that the field is really growing. I think personally for me, I think so some of the different ways I've seen people get involved is often you can like have like a machine learning internship at a startup where you're basically just building out their pipeline for solving like a particular machine learning problem. So I think those are like some of the internships you'll see like being posted a lot. I think more and more companies have dedicated like machine learning engineers who are working on like massive systems that already exist in the company, and they're improving efficiency, they're improving speed, they're improving performance, and all of those things are like really like exciting because you're tackling machine learning from like a systems perspective, you're tackling it from a hardware perspective, you're tackling it from like really low level like code perspective. So it's really exciting to like look at someone approach machine learning from all these different angles, right? So all of these different positions are cropping up. I think that there's also more interest in like having dedicated like ML research scientist teams who are working on like innovations in areas where like particular companies are really interested in. So you have people with image teams, you have sort of multimodal like vision text teams, you have all these sort of research teams that like even a few years ago, like the postings for that were like very few. And now like a lot of industries are really excited about machine learning and they're trying to hire a lot of good like individuals who are like interested in working in those areas. So in general, I think that like in general, there are a lot of opportunities in machine learning. I think that well, yeah, I think the PhD aspect of it is just like I think yeah that's not something I can really speak to because I haven't finished, right? I haven't looked at the PhD postings in too much detail yet. So I feel like that's just yeah.
Yeah, jobs are popping crazy, but the difficult part is people are choosing AI engineers who just learned how to train an LLM in 2023, 2024 over someone who has an LLM experience of 2016. That is how fast it is changing. You said it right. And your PhD degree right now, or your MIT degree right now, or your knowledge right now is more important than someone's machine learning knowledge 5 years ago. It's that crazy. And you're right that we have to every single year there's no shortcut to hard work. You have to show experience which is the latest, right? You agree?
I think well, I will say that like some amount of like longevity in the field is important. Like I think a lot of experienced like researchers in AI are finding a lot of renewed interest in their works. So I think that being in AI for a long period of time is definitely like helpful. But with that being said, I just think there's generally just more openings in general which are hiring for like different levels of experience. So I think that for certain like roles, employers don't really like see having a PhD as that necessary for what they're trying to do and what kind of models they're trying to build. Whereas in other kind of roles, they're just looking to like open up teams and like have like research scientists lead those teams. So I think, you know, I really think that it's just like whatever fits for the company and whatever works for the company in question. So yeah.
Uh-huh. Do you think we're gonna go into the future of more tokens being processed? Because it's impossible. For example, Gemini introduced their 2 million token window, 2 million token context. That means you can put 10 Python libraries that a human cannot learn in months or years. You can learn in 1 minute using those context windows. Do you believe future is even bigger?
I think that yeah, we're definitely going to see like bigger, more and more context windows. Like I think a lot of exciting research is going on in that area. I also think that like we are also seeing interesting research in the other direction, which is what you want to shrink your models so that they run locally on your phone, on your laptop, and stuff like that. So I think that a lot of research is also going into like figuring out how to make models work well in those contexts. So I think I think there are many different ways machine learning as a field is evolving, and I think those are really exciting. So yeah.
Sure. एंड लास्ट हिंदी में एनी फाइनल एडवाइस कि कोई हाई स्कूल का स्टूडेंट अगर आपको देख रहा है ही लाइक ट्रीट्स यू एज अ बड़े भैया जो आपकी तरह एमआईटी में जाना चाहता है वांट्स टू एंटर द वर्ल्ड ऑफ एआई क्या आप दोगे?
ठीक है तो एमआईटी में So first of all, cliche है, but follow your passions. अगर आपका passion STEM है, तो definitely like pursue it as much as you can. School के अंदर, school के बाहर, whatever opportunities you're getting, like learn more about science, learn as much as you can, and participate in competitions where like you get to do research, you get to do projects, you get to like show like your science knowledge and like share discuss science with the rest of the world. एंड आई थिंक दैट वो ना मतलब बहुत ही रिवॉर्डिंग होता है इन एंड आउट ऑफ इटसेल्फ कॉलेज आपका रिजल्ट जैसे भी आए लाइक वो अपने आप में ही बहुत लाइक सेटिस्फाइंग होता है एंड आई थिंक अनदर पीस ऑफ एडवाइस अगर ऐसे लिस्ट चाहिए कुछ अपॉर्चुनिटीज़ की या ऐसे कोई आपको टिप्स चाहिए तो गो ऑन लाइक सर्च लाइक एनरिचमेंट अपॉर्चुनिटीज़ ऑनलाइन ऑन स्टेम एनरिचमेंट अपॉर्चुनिटीज़ एमआईटी का एक पेज है जिसमें वो लोग काफ़ी सारे ऐसे अपॉर्चुनिटीज़ लिस्ट करते हैं एंड बहुत सारे ऐसे समर प्रोग्राम्स समर कैंप्स और लाइक बहुत सारे ऐसे रिसर्च कैंप्स हैं जहाँ पे मतलब आप पार्टिसिपेट करोगे आपको रिसर्च करने को अपॉर्चुनिटी मिलेगा आपको लाइक टॉपिक के बारे में पढ़ने को अपॉर्चुनिटी मिलेगा एंड ऑफन टाइम्स लाइक दे डोंट इवन हैव लाइक अ फाइनेंशियल कॉस्ट इज लाइक अ बैरियर क्योंकि उसमें स्कॉलरशिप भी होते हैं तो परस्यू दीज काइंड ऑफ अपॉर्चुनिटीज एज मच एज यू कैन अगर आपका पैशन स्टेम है और अगर आपका पैशन स्टेम के बाहर भी है आप ह्यूमैनिटीज में भी ऐसे अपॉर्चुनिटीज ढूंढ सकते हो आप ऐसे परस्यू कर सकते हो देयर आर ओलंपियाड्स इन लिंग्विस्टिक्स एंड फिलोसफी व्हिच are like becoming more and more popular nowadays and India is sending teams there so like participate in those kind of competitions and it's just just enjoy your high school like your middle school and high school years in general like colleges look for like across the board they look for like passion and dedication to your subject तो अब एक स्पेसिफिक कॉलेज को लाइक मैं लाइक आई एम नॉट गोना से एक स्पेसिफिक कॉलेज में ऐसे घुसना लाइक आप गारंटी कर सकते हो बट मैं कह रहा हूँ कि इन जनरल आपका जो चांसेस हैं वो अच्छे होंगे अगर आप अपने पैशंस को फॉलो करोगे इन दिस रिगार्ड सो या
And totally, starting early is important. Age is not a barrier. Age barrier है alcohol के लिए, but not for learning. You can learn as early as possible. Absolutely. Yeah, awesome. Thank you so much, Sagnik. It was wonderful talking to you. Got so many insights into the era of AI innovation that I had never heard about. Learned so much, and I am going to do my homework, go deeper into your learnings. And thank you so much again.